Again, your objective for this new part. It says students will solve problems dealing with angles formed by transversal crossing parallel lines. Before we go any further, let's talk some definitions here. Parallel lines. Two lines that are in the same plane, and that is important. They must be in the same plane because, again, the board here is a plane. If I say it's two lines that never cross, well, what if they're not in the same plane? What if one is going this way and the other one's coming straight out at you? Those are not parallel lines. Those are called skew lines. Well, this one's in this plane, but the one that's coming out at you would not be in the same plane. That's not parallel lines. Those are skew lines. They never cross, but they're not parallel. Parallel lines lie in the same plane. They go on forever. They never cross. I don't have to know it this lesson, but does anybody remember what's true about their slope? Same slope, good. The slopes of parallel lines will always be the same. And again, not in this lesson, but if you have perpendicular lines, they have opposite reciprocal slopes. Remember that? So two lines, same plane. Got two lines. These lines are parallel. And what we're going to be talking about today, definition-wise, two lines that are crossed by another line. This third line is called a transversal. It transverses the other two lines. So parallel lines cut by a transversal. There's a good possibility you've discussed this in previous math classes, that you've seen this before. Anytime you have parallel lines cut by two transversal, you have 1, 2, 3, 4, 5, 6, 7, 8 angles formed. And these 8 angles are going to have special names, and that's the first thing we're going to be talking about. And here they are. Again, a transversal is a line that intersects two coplanar. We all know what coplanar is. It means a line in the same plane. Crosses two coplanar lines at two distinct points. Crosses right there and right there. It forms 8 angles, and it doesn't matter how you number them, but there's 8 of them. There are 3 words. Actually, yeah, well, four sets of words that you need to know. Alternate or alternate. And we all know what it means to alternate. It goes from one to the other. It goes back and forth, right? When we're dealing with alternate angles, then they're going to be on different sides. 5 and 3 are on different sides of the transversal. 4 and 2 are on different sides of the transversal. 7 and 2 are on different sides of the transversal. That's what it means to alternate. To go from one side to the other side. And we all know what, I'm not going to go over this, but same side. We all know what angles are on the same side of the transversal. 1, 5, 4, and 7 are all on the same side. 3, 6, 2, and 8 up there are all on the same side as well. So we got alternate angles that are on different sides, and we have same side angles that are on the same side. And then we have what's called interior and exterior angles. Interior, exterior. Think about a house. The interior of the house is where? Where's the inside? Thank you. And the exterior is outside. Okay, now let's talk about here, interior angles. Your interior angles, these are your lines. Your interior angles are on the inside. Those are interior. Your exterior angles are on the outside. So 5, 6, 7, 8 are exterior angles. 1, 2, 3, and 4 are interior angles. Okay, now let's put that stuff together. Alternate interior angles. Alternate means on one side or the other side. Interior on the inside. 1 and 2 are both alternate angles and interior angles. 1 and 2 are alternate interior angles because they're on different sides of the transversal and they're on the inside, 1 and 2. Angles 3 and 4 are also alternate interior angles. One's at the top, one's at the bottom. 1 and 2 are alternate interior, 3 and 4 are alternate interior. Same side interior angles. 1 and 4 are on the same side of the transversal and they're on the inside. Those are same side interior angles. 2 and 3 are also same side interior angles. Corresponding is one we didn't go over. Okay. One thing I want to point out: there's 4 angles up top, and there's 4 angles down bottom. Corresponding angles are the angles that lie in the same place. In your top set of angles, angle 5 is in the top left-hand corner. Well, go down here. Which one's in the top left-hand corner? Angle 4. Angle 5 and angle 4 are corresponding angles. Well, 6. 6 is in the top right-hand corner. 2 is in the top right-hand corner. Those are corresponding angles. 7 and 1, 8 and 3 are also corresponding angles. Now, tack this on the bottom. For some reason, they leave these off. But alternate exterior and same side exterior. Let's go ahead and throw those in. Alternate, from what we've learned here, alternate, okay, one's on one side of the transversal, one's on the other side. Exterior means they're on the outside. So from this up top, you got 5, 6, 1, 3, 4, 2, 7, 8. One more time, Cole, which ones were exterior angles up there? 5 and 6 and 7 and 8. So alternate exterior. 5 would be alternate exterior with anybody? 5 and 8. Alternate exterior on opposite sides and they're on the outside. 6 and 7 would be alternate exterior. And then same side exterior. Same side exterior, 5 and 7 are on the same side, right? And they're both exterior. 6 and 8 are on the same side and they're both exterior. So 5, 7, 6, and 8 are same side exterior. So let's go over all these again. Let me number them different. Parallel lines, cut by a transversal. Let's do 1, 2, 3, 4, 5, 6, 7, 8. Doesn't matter how you number them. That's just names for these angles. If I ask you for alternate interior angles, first off, you need to remember what interior is and alternate is. Alternate interior would be 3 and 6, 5 and 4. Alternate interior. Let's go to alternate exterior. Ethan, help me with it. Alternate exterior. 1's on the exterior. What's alternate exterior with 1? 1 and 8. Good job, Ethan. What about 2? 2 and 7. Those are alternate exterior. Then you have same side interior. And I don't care for you abbreviating it like this if you want to. Abby, help me with it. Same side interior. Here's your interior angles. Abby, give me a couple of sets of same side interior. Okay, thank you. Nicole, help her out. Same side interior. 4 and 6, or 3 and 5. Good job. Good. Same side exterior. Rachel. 2 is an exterior angle. What's same side exterior with 2? Careful. Exterior. 2 and, this is interior here, right? So 2 and 8, 1 and 7. Those are same side exterior. And then the last one that you need to know is corresponding. Kyle, angle 2 up here corresponds with what angle down here? Correspond, same place. 2 and 6. Does everybody see that? 1 and 5, those are corresponding. 3 and 7 correspond. 4 and 8 correspond. Okay, now that we've gone through all that, what does that mean to us? And I wished I had the applet that would do this. I don't think this one works quite like I would like for it to. The first of these is a postulate, and you might want to write this down. Notice it says corresponding angles postulate. A reminder, a postulate is a common sense statement. What this common sense statement says, if you've got parallel lines cut by a transversal, okay, parallel line, let me draw a bigger set of them. Parallel lines cut by a transversal. And you've got these two angles that are corresponding. What I want you to imagine, take and chop this off, and take this set of angles and slide them down on top of that set of angles. What's true about angle 1 and angle 2? What do you think? If the angles, or excuse me, if the lines are parallel, angle 1 and angle 2 will be the same side. Okay, slide it down. Okay, again, imagine this is the same distance. Slide this down perfectly right on top of that other angle. Okay, if it slides down, would this angle not match up exactly with that angle? So your first postulate says, if two parallel lines are cut by a transversal in this manner, corresponding angles will always be congruent. So this angle is congruent to this angle. This angle is congruent to this angle. This angle congruent to this angle. And this angle will always be congruent to that angle. Corresponding angles will always be congruent. Here's one way you could write it. Parallel lines implies corresponding angles congruent. Learn how to abbreviate, right? Parallel lines will imply. That's an if-then statement. We've talked about if-then statements. This whole class of geometry was based on if-then statements. If you have parallel lines, that implies that corresponding angles will be congruent. Let's go a step further. Since corresponding angles are congruent, Stephen, angle 1, from what I just told you, angle 1 has to be congruent to what angle down there? What corresponds with 1? Okay, Vanessa, thank you. Angle 1, Vanessa, corresponds with 5. 1 and 5 are the same size. Everybody understand that? Slide it down. They're in the same spot. 1 and 5 are the same. Megan, angle 2 is congruent to what angle? 6. Destiny, angle 3 is congruent with 7. Good. And Sydney, angle 4 is congruent with 8. Go a step further. What about alternate interior angles, alternate exterior angles, same side interior? Let's go through that whole list. Guys, revisit the last chapter we talked about. What's true about 1 and 4? Ignore this down here. Does that shape look familiar? The two intersecting lines? I know it's been a long time, like a month since we've been here. But does anybody remember what angles 1 and 4 are called? Starts with a V. Vertical. Angle 1 and angle 4 are vertical angles. Angle 2 and angle 3 are vertical angles. Angle 5 and 8 are vertical. Angle 6 and 7 are vertical. So I know that 1 and 5 are congruent, correct? What's true about 1 and 4? They're congruent as well, right? Because vertical angles will always be congruent. So let's say that this is, 100-degree angle. Well, don't we know that these correspond, so wouldn't that be 100? Well, these are vertical, wouldn't that be 100? What's the relationship between these two? From what we just named them, those two sets of angles are alternate interior. So now what can we say, because vertical angles are congruent, corresponding angles are congruent, so now I can say, well, guess what else? Alternate interior angles will also be congruent. I just did a proof and you didn't realize it. We just proved that. Here in a second, I think they actually asked us to go through the formal proof of it. And the way that you would do that, well, angle 1 and 4 is vertical, those are congruent. 1 and 5 are congruent because parallel lines are cut by transversal, corresponding angles are congruent. Well, if 1 is congruent to 4, 1 is also congruent to 5, why can't we say 4 is congruent to 5? Does anybody know what property that is? It's been a while. If one thing is equal to something, and that same thing is equal to something else, then those two things would have to be equal as well. That's called the transitive property. I just used the transitive property to prove that. Now let's go a step further. Isn't 5 and 8 also congruent because they're vertical? So wouldn't 8 also be 100 degrees? Well, what's the relationship between 1 and 8? Alternate exterior. So therefore, let's start making this a list. If you have any of these, they're going to be congruent. What angles are congruent? I'd probably put this somewhere on my paper. You have alternate. Well, let's start with the one that they gave us. First off, we know corresponding. That's a postulate. Corresponding angles will always be congruent. Alternate interior angles will always be congruent. Alternate exterior angles will always be congruent. Which ones do we not have on our list? Same side interior, same side exterior. Let's see what's true about those. Hunter. Angles 1 and angle 2. Angle 1 is, let's say, 100 degrees. How big is angle 2 then, Hunter? And how do you know? 80 degrees. Does anybody know why? Angle 1 and angle 2 form a straight line, so therefore they are a linear pair, so therefore they are supplementary, which means they add up to 180. Okay, now let's go through that whole spiel again. Well, isn't 2 and 3 vertical? So that makes that 80. Isn't 3 and 7 corresponding, which makes that 80? Isn't 7 and 6 vertical, which makes that 80? So now the question is, what's true about same side interior and same side exterior angles? Here's a set of same side interior. One of them's 80, the other one's 100. Here's a same side of interior angles. One of them's 80, the other one's 100. So those are supplementary. So your supplementary angles would be your same side interior. What about same side exterior? 2 and 8 are same side exterior. 1 and 7 are same side exterior, so therefore those would also be supplementary. So to make a long story short, when parallel lines are cut by transversal, corresponding angles are congruent. Alternate interior angles are congruent. Alternate exterior angles are congruent. Same side interior angles and same side exterior angles are supplementary. So here's your theorem. Don't write. You just wrote this down. Okay? You don't have to write this down again. You just wrote this down. If a transversal intersects two parallel lines, then alternate interior angles are congruent. Already know that. 1 and 3 is congruent. If a transversal intersects two parallel lines, then same side interior angles are supplementary. Just wrote it down. Same side. Anytime you have same side anything, that's the only time they're supplementary. Same side interior, same side exterior. Those are always supplementary. Transversal intersects parallel lines, then alternate exterior angles are congruent. Transversal intersects two parallel lines, then same side exterior angles are supplementary. You just wrote all that down, but we didn't use near as much paper. So here's your first problem. And these are pretty easy. If you honestly, you don't have to use a lot of new stuff to do this. In the figure, the measure of angle 5 is 72 degrees. I'm going to mark it out and put 72 degrees right there. Find the measure of each angle. And not only do I want you to be able to do that, but I also want you to be able to tell me why. Okay? Jordan, just tell me any angle. This one's 72 degrees. You can tell me 1, 2, 3, 4, 6, 7, or 8. Tell me how big they are. Any of them. 4 is 72 degrees. And this is the hard part. I also want you to be able to tell me why. Jordan, what's the relationship between those two angles? I know they're congruent. What type, bless you? What type of angles are those? Corresponding. Corresponding angles will always be congruent. Sierra, give me another one. 7 is also 72 degrees. There are 2 reasons why. You can tell me either one. How did you do it? I did vertical angles. That's the easiest way. And that's how you would explain to me, well, vertical angles are congruent. Or she could have said alternate interior angles are congruent. And there's one more, Jordan P. There's one more that's going to be 72 degrees. Which one is it? Good. So this one's also 72 degrees. And there's 3 reasons why. You could either say, well, these 2 are vertical. Or you could say these 2 are what type? Anybody? Corresponding. Or you could say these 2 are alternate exterior. Alternate exterior angles are the same. Corresponding angles are the same. Alternate interior angles are the same. And let's do it the easy way. JC, all the other angles are how big? 108. Because these 2, you could do it like this. These 2 angles are supplementary because they form a linear pair. These 2 are supplementary because they form a linear pair. These 2 are vertical. These 2 correspond. These two are vertical, or you could say these two correspond. These two are alternate exterior. These two are alternate interior. You could all those different reasons you could tell. Or you could say, well, these two are same side interior and they're supplementary. This one and this one is same side exterior and those are supplementary. Next problem, then we'll move on. Find the measure of each angle. It says justify each answer. You can we'll go through and I'll justify it for you. Jackie, any of them. You got a 50-degree angle. Tell me 1 through 8. Which other one do you know? Angle 8 is also 50. And if I ask her to justify that, she'd say because those two angles are vertical. We need to know those words. Why do we need to know those words? Because now we're starting to do proofs. And if I ask you to prove, let's say I just said, prove that angle 5 is 50 degrees. And you might have to justify this, and the way you would justify it is, well, in this case, these two angles are vertical. You would have to know those definitions, those actual words. Carson, any others? 7 is 130. Because these two angles form a linear pair. Chris, know any of them? You know any 1, 2, 3, 4, 5, 6? Any of the other angles? Perfect. 5 is also 50 for two different reasons. These two are alternate interior. Let me show you something else. Let's stop for just a second. Alternate interior angles are always Z-shaped. Y'all see the Z there? This angle and this angle, those are alternate interior angles. Anytime you have a Z shape where this is parallel to this, you see the Z here? Look, we've got right here. It's actually a backwards Z. Anytime you have that Z shape with your parallel lines, those are alternate interior angles. These two are alternate interior, therefore they're going to be the same. Now these two, there's another reason. These two are going to be corresponding. Anytime you have corresponding, you have F shapes, where this and this correspond, or you might have like a backwards L, where this angle corresponds with this angle. And you see that here. You've had actually an upside down F, didn't you? Upside down and backwards. Anytime you have that shape, you have corresponding. Caitlin, do you have any other angles? Number 1 is also 50 for 3 reasons. This one and this one, alternate exterior. This one and this one's vertical. This one and this one are corresponding for any of those reasons. Let's just go through the other ones. Brianna, any of the others? 6 is also 50. Good job. Erica? Two shouldn't be too bad. 130, good job. And then 3 and 4. Claudia, you know either one of those? Are both 50? Careful. Because this one's 50, this would correspond with it. Y'all see you got parallel lines going in both directions? So you've got, here's parallel lines. If this is 50, this one's in the same spot. It would also be 50, so what would this be, Claudia? Good. So 130, and we'll go ahead and knock that one out. That is also 130. They didn't ask for them, but this one's 130, this is 50. Do you notice something, and I'm getting ahead of myself here? This is parallel lines, 2 sets of parallel lines. Does anybody know what shape this is in the middle? What that's called? 4-sided shape, opposite sides are parallel. Parallelogram. And you just learned something about parallelograms. Look at your angles inside that parallelogram, and this is always true. And we'll discuss this later on, I think in chapter 5. Anytime you have a parallelogram, your opposite angles will always be the same, won't they? Opposite angles will always be the same. The angles next to each other will always be supplementary. Moving along. Here's some algebra. Of course, we have to throw in algebra. The first thing that you need to know, and please don't just say they're equal right off the bat. When parallel lines are cut by a transversal, you'll either have equal angles or supplementary angles. You'll have 2 sets of angles. They're either going to be equal or they're going to be supplementary. Here it gives you the measure of angle 3 equals this. And here's 3. The measure of angle 7 equals this. And here's 7. Does everybody see the Z? Zoe, 3 and 7. Are they supplementary or are they congruent? Supplementary. What's the relationship? Are they alternate interior, alternate exterior, same side interior, same side exterior, corresponding? They're on different sides, right? There you go. They're on different sides, so they're alternate. And they're on the inside, so they are interior. What's the relationship always between alternate interior angles? Anybody? Yep. Always congruent. Alternate interior angles will always be congruent. Okay, now that I've told you all this complicated stuff, here's the easy way to remember it. Does everybody know the difference between acute and obtuse? Angle 3, is it acute or obtuse? Acute. Angle 7, is it acute or obtuse? So they are the same. All your acute angles will be the same. Look at 7 and 4. Are those angles going to be the same? Guys, that's an obtuse angle. That's bigger than 100. That's smaller than 100. They're not the same. So anytime you're dealing with these, the easiest way to remember, if no other way, all the little angles are the same, all the big angles are the same. That's all. So there, 3 is a little angle, 7 is a little angle, they're the same. So to set this up, angle 3 has to be congruent to angle 7. Let's solve this in our head. Cole, take my y's and move them to the right side. How do I move 4y? So I now have how many y? Good. At the same time, Cole, take this 6 and let's move it to the left side. You're at plus 6, you got to do minus 6, and what do you now have? So y must be 8 after you divide. Am I good with that? If y is 8, that means the measure of angle 3 is no longer 4y plus 30, but 4 times 8 plus 30, which is 62 degrees. And this would be 56 plus 6, which is also 62 degrees. Think about what I could ask you on your test. I could give you this exact same problem. Find y if this is this and this is this. And then I could say, okay, now what's the measure of angle 2? They're not. And that tests you on so much more because if I ask you for the measure of angle 2, you've got to go through this whole spiel. You've got to solve the equation. Now that I know that y is 8, now I have to plug it in and see that this is 62. But if I want the measure of angle 2, well, those are supplementary. You'd have to subtract from 180. That'd be 180. So I could go a step further on your test. There's a good possibility I'll go a step further on your test and ask you, because you know all the angles now. 118, 62. 118, 62. 62, 118, 62, 118. You know them all. Another one. And I'll give you a second to set this one up before I get started. Just wanted you to set it up. The measure of angle 4 is this. The measure of angle 1 is this. Now the question is, are those two things equal, or are those two things supplementary? Let's find Ethan, 1 and 4. Here's 1, and here's 4. Ethan, what's the relationship between 1 and 3? One and 3 are vertical, right? So they're the same. All right, 1 and 3. So what's the relationship between 3 and 4, though? Same side interior, so they are the same or supplementary? These two. Are they? Look, that's a little bitty angle. That's a big angle. So they have to be supplementary. Does everybody follow that? Well, if 3 and 4 are supplementary, and 1 and 3 are the same, does that not mean that 1 and 4 would have to be supplementary? So do I put an equal here? What do I put here? Plus equals 180. When you add the two angles together, you will get 180. So now take minus 17 and plus 85 and move it over, or just put them together and then move it over. If I put them together as they are here, I get 68. Isn't that right? So these two together are 68, so just come over here and do minus 68. You can do it either way. And that gives you 112. Does anybody have X yet? Good job. So x is 56. So that means measure of angle 1 was 85 degrees. And you can check it. 2 times 56 is 112. 112 minus 17 is also 85 degrees. Good job. Here's a nice one. Find the values of both x and y. Nicole, do you know either one of them, x or y? I would start with x. How big is x? It is 70 degrees. Here's what I need you to picture. And I used to have to do this when I took geometry. This is not the whole parallel line. If you need to draw these things on further, and you need to draw that on further, parallel lines cut by transversal, this angle and this angle are corresponding angles. Or another way you can do it. One more time, guys. Anytime you see an F shape, those two angles are corresponding angles. That's an L. That's an F that's laying on its back, flipped over, okay? These angles correspond with each other. So if that's 70, that's 70. Okay, now we got to find y. This is, I'm not going to call it a linear pair. But I do see a straight line. The reason I'm not going to call it a linear pair is because there's more than two angles there. Same thing applies though. If you have three angles that once you put them together form a straight line, those three angles would have to add up to 180. So if I have 70, I have another 50. That leaves me with how many, Rachel? 70, 50, and I think you said 60. Adds up to 180. That makes sense. Okay. Here you have a different shape. It's a type of quadrilateral. The reason we call it quadrilateral is it has four sides, but it is a special type of quadrilateral. The top and bottom are parallel. This is not a parallelogram. This is a trapezoid. There you go. Anytime you have a quadrilateral with one set of parallel sides, it's called a trapezoid. Go ahead and learn it now. You won't have to learn it down the road. Trapezoid has one set of parallel sides. A parallelogram has two sets of parallel sides. Now, we can apply what we just learned to trapezoids because we've got parallel lines. Anytime you have parallel lines and they are cut by a transversal, this is a transversal. Y'all see that? Then we know alternate interior, alternate exterior, and corresponding angles are congruent. We know that same side interior and same side exterior angles are supplementary. What is the relationship, Kyle, between this 2x and this 90-degree angle? Are they alternate interior, alternate exterior, same side exterior, or corresponding? Same side interior. And same side interior or same side exterior will always be supplementary. 2x plus 90 has to equal 180 degrees. You didn't have to do it like that, did you? Because if you know that these two are supplementary, this is 90. Do you not also know that that's 90? So you could have just said 2x is 90 if you wanted to. But is that the same thing? Move that 90 over. You get the same thing. So if 2x is 90, x must be good. The second, Vanessa. You again have parallel lines cut by a transversal. They don't draw the whole parallel line. They don't draw the whole transversal. But these two angles, y minus 50 and y, are they same? Excuse me. Are they alternate interior, alternate exterior, same side interior, same side exterior?